Good afternoon and welcome to our exciting live webinar on GPT for enterprise data. Thank you for taking the time to join us from all over the world today. My name is Anila Pilipovic and I'm a Senior Account Executive here at Authority Partners. I'm thrilled to be your moderator for today's exclusive event. We are honored to have such a great turnout and are excited to deep dive into the topic of GPT for enterprise data. But before we begin, I want to go over a few housekeeping items. Firstly, we set aside 15 minutes for Q&A at the end of the webinar. So please submit your questions at any time by typing them into the question window on the bottom right side of your screen. We'll do our best to answer as many questions as possible before we wrap up. But if we run out of time, we'll follow up with you via email. And secondly, if you would like to have more in-depth private conversation about any of the topics discussed today or any of Authority Partners service offerings, please use Skip the Line link in your registration email or webinar registration page. But without further ado, I'm excited to introduce Errol Karabek, President and co-founder of Authority Partners. Errol will be leading today's discussion on GPT for enterprise data. So sit back, relax, and enjoy the presentation. Errol, take it away.
Thank you, Anila, and warm welcome to all of you joining us here today for this webinar on GPT and its applications in private enterprise data. I hope I will be able to share some of my excitement about generative AI. It's easy for me to get excited about cool new tech like GPT, but this is something entirely different. I had a chance to see the internet, .com, mobile, social, and crypto bubbles unfold firsthand, so I can definitely separate the hype from the substance. I know that we are at the brink of new technological revolution, and opportunities in front of us are amazing and a bit scary as well. So what is it about neural networks and specifically about generative AI and language models that makes me so excited? Here are, in my opinion, some of their most interesting traits. First of all, they learn about a topic in the same way that we can by reading about it. ChatGPT, for example, was trained on 570 gigabytes of text. It doesn't sound like a lot, but that is the equivalent to about 1 million books, 300 pages thick. Second, language models get a lot smarter as they get bigger. GPT, for example, has about 175 billion parameters or synapses. This is just 4 orders of magnitude less than the number of synapses in the human brain. It has tested IQ of 147, which is 99.9 percentile on verbal linguistic IQ test. Various universities put it to test, and it passed US bar exam, CPA certification exam, MBA degree exam, and a US medical licensing exam. It also passed Google L3 software developer test, and for your reference, that role at Google has a salary of $183,000 per year. Number 3, large language models understand the meaning of our questions and can produce well-crafted long-form answers. So people are indeed asking these models a lot of questions, and GPT is currently outputting more than 300 million words per second, or the equivalent of entire printed works of humanity every 2 weeks. And finally, large language models can learn from just one or few examples and then give intelligent answers about the topic. So this is what we call the phenomenon of a few-shot learning. We'll use that a lot today. So basically, if you give a model some data, like your product description or a corporate policy or an analytics report, you, your customers, and everyone else can just ask that model any question about that data in natural language, and the model is going to answer. I think that's pretty cool. Now that I hope we agree that language models are cool, let's talk about how we can use this technology in our business. So one way to do it, of course, you can train your own model. There is a large number of open source implementations and even pre-trained models. Hugging Face, for example, lists more than 170 large language models. So if you have valuable large private data set, this may be something you want to do. However, as we just mentioned, the bigger the model is, the smarter it is. And to train really big model, you need a lot of resources. OpenAI, for example, the makers of ChatGPT and the GPT family of models, they have 1,000 data scientists, more than 1,000 data scientists, the best of whom are paid about $2 million per year. It took this whole team 12 to 18 months to prepare the training data set for GPT-3 model. Then they used some 10,000 GPUs and 285,000 CPUs for several months of training and millions of dollars of compute cost. So this is clearly not the path for everyone. Then you could consume existing models the way they are without changes. So this is an exciting area that will surely consume a lot of engineering hours across the world. I have to admit, we started here as well, and we are still getting better at it. Adding generative AI to your existing workflows and tools gives immediate benefit. We explored automatically adding unit tests to developer code, commenting and summarizing pull requests, and so on. I believe there may be use cases where just consuming existing language models works just great. But we are here to talk about augmenting existing models with your private data. Since our company is usually building large enterprise systems, this way of using generative AI technology presents the largest number of opportunities to our clients. As I mentioned, it's very expensive and time-consuming to train a language model today. However, big models are getting really good at few-shot learning, which means if we can somehow find the data that is relevant to the question our user is asking, we can pass that data to the model together with the question, and the model will answer intelligently more often than not. Today's webinar is going to explain how we do this. So here's our agenda today. To understand how this actually works, we'll first explore fundamentals of GPT and other key building blocks that Authority Partners uses to transform access to private enterprise data. Then I'll demonstrate an internal solution that allows our consultants to access knowledge contained in our company policies. After, we'll talk about several enterprise use cases that can be vastly improved with generative AI. And finally, we'll share some insights into how we approach GPT for enterprise data engagements with our clients. As you can see, we have a lot of ground to cover, so let's get going. To help us make today's session as valuable as possible to most people, let's start with the poll. Please take a moment to answer the question you see in the polls window. You can find polls window in the bottom right-hand corner of your screen. And the question is, what best describes your interest in GPT for enterprise data? So basically your options are, I'm just curious, or I'm thinking about a use case, but I don't know if the technology is applicable, or I have an idea for a project and I need a team to do it, or I already have an ongoing generative AI project and I just want to learn about others' approaches and experiences. So your input will help us tailor our presentation to best meet everybody's needs. Let me see what people are answering. Okay, so we have a number of answers already. I see that a lot of us are in the beginning of this journey. Some are already going and doing projects. Okay, great to know. I see where we are. Okay, so let's get going. So we'll begin, as I said, we'll begin by revisiting the underlying technologies that form the building blocks for any GPT for enterprise data solution. And please excuse me for going over some of the topics that most of you know. I'll try to be very brief. However, some of the points on this journey are important for understanding how GPT does what it does. So please bear with me for the next 5 minutes or so. So let's start with machine learning. So we wanted to have intelligent machines from the very beginning, and computers that could communicate with us in our natural language, that could help us be more productive in the complex world. But while we were able to get computers to calculate rocket trajectories and spreadsheets, it was very hard to get them to recognize faces or understand natural language or do many other tasks that even a child can easily perform. The reason for this obviously is complexity. there are just too many parameters involved in these intelligent tasks, which makes them unsuitable for classic software development methods. Because remember, traditionally, the only way to get the computer to do something was to write an algorithm explaining how in tedious, minute detail. But if a programmer or a team cannot learn all of the necessary parameters, then can we make some kind of algorithm that can do that? And it turns out that yes, we can. Machine learning algorithms learn how to do complex tasks on their own by making conclusions from data. And typically, the more data they have, the better they get. So with machine learning, we don't program computers to do tasks, we program computers to learn how to do tasks. And how does this happen? So one approach to do this is trying to model how people think. And in our brains, as you know, the basic unit of calculation is a type of cell known as neuron. So we'll skip through many interesting details here, but just remember that one of the crucial functions in signal processing in our brain happens where neurons connect in the synapses. So where signals being passed from one neuron to the next can be increased or decreased in transmission. Like the biological neuron, artificial neuron or perceptron is a fundamental unit of computation in an artificial neural network. It takes more than one or more inputs. It has an output. And remember, the biological neuron with synapse, we have the same model here. Every input to our artificial neuron is multiplied by something called a weight, this little W here. And then that weight is modifying the input by either increasing or decreasing that input. Training the network really involves adjusting those weights so that network of these neurons remembers the pattern that it found in the data. So moving on, neuron obviously by itself is not as exciting or as useful. We connect them into a network of neurons. So each neural network has an input layer where we pass the data into. It has hidden layers, and then it has output layer where we read the outputs, predictions, or whatever the network needs to do. So one example of one of the first successful neural network architectures was this feed-forward network. Pretty simply, in feed-forward network, all layers are connected to each other. Every neuron in the layer before is connected to every other in the layer after it, and they all connect to some sort of output. It can be multiple neurons in the output. So in this particular example, this network is used to recognize fraudulent credit card transactions. We pass it some data, it recognizes the pattern and tells us, is this a fraudulent or not? These types of networks are really good for pattern recognition, but how do they learn what they to recognize those patterns in the input data? So there are two main types of learning in neural networks, supervised and unsupervised. In supervised learning, the network is trained using labeled data, while in unsupervised learning, the network is trained on unlabeled data or just raw data. So obviously, if we could train everything using unsupervised learning, basically, just the network learning by itself using that data, it would be great. However, supervised learning still plays a huge role because we kind of tell the data, tell the network what to look for, and then later we let the network work on the raw data. So one of the algorithms that's really important is backpropagation. So we'll talk a little bit about that because GPT uses backpropagation heavily, both in unsupervised and supervised mode. Backpropagation, as its name tells us, is basically an algorithm where we calculate the difference between the output that the network is giving us and the actual result that it should be giving us. So that's an error. And then we propagate that error backwards through layers of neurons, adjusting those weights. If you remember, we talked about synapses and weights that are simulating those synapses between neurons. So we are adjusting those weights, walking backward through the network so that error in the end is minimum or zero, right? So back to our fraudulent credit card transaction recognition network. If we want to recognize that fraud, obviously we are going to train this network first on a labeled data, which means we have the amount of transaction, terminal where the transaction was made, country where it is made, or whatever other feature in the input data. And we'll tell the network, okay, this is fraudulent or this is not fraudulent. So that once it comes back, we can compare, okay, so what did the network predict? Okay, is it fraudulent or not? We make the difference. We try to adjust the weights and so on and so forth until the network starts to recognize fraudulent and transactions from the normal transactions. However, these feed-forward networks cannot really recognize the data that has time dependencies among its agents. So some sort of series of data samples that are connected to each other, either in space or in time. To deal with that problem, computer scientists and engineers invented a series of different neural network architectures. So the next one is a recurrent neural network that keeps the state. It's kind of a memory cell, really, that keeps the state from the previous samples. So a series of samples that have some sort of temporal relationship with them, like the case is with the text or speech or video. We can kind of remember from frame to frame, from one sample to the next, what was the previous one, and try to connect them together and make sense of those dependencies. Recurrent neural networks do that for us, and they are pretty successful. Next architecture that I just want to mention in this evolution of neural network architectures is the convolutional neural networks, which were really great for finding spatial relationships within the data. Convolutional neural networks would just apply different filters to the input, like different resolutions, different lighting and stuff like that, and figure out is this one object in the picture, several objects, and so on and so forth. However, none of these architectures really could address one simple problem that we come into every day, and that's the language translation. So if you have a piece of text or speech in one language and we want to translate into a different language, none of these previous network architectures could deal with this problem efficiently. And typically, we always have these two blocks, encoder and decoder, in these types of tasks. So encoder kind of extracts the features from the input and then passes them to decoder, and the decoder then tries to generate the output. As I said, none of the previous architectures really worked until 2017, when a group of scientists came up with this self-attention method, or actually more specifically multi-head self-attention method, where they figured out a neural network architecture and with a bunch of matrix math that can actually make sense of relationships between words in a sentence. So which word in a sentence relates to other words in the sentence, and so on and so forth. And they came up with this revolutionary new software neural network architecture called transformer neural network. Transformer neural network, pretty complex. I'm not going to go through all of it, but it heavily uses this multi-head attention layers all over, and is able to is really able to much better transform one text input to a different language, or even to some other forms of communication, sound, video, whatever. So now that we know enough to attempt to decipher the name GPT, let's take a closer look at the Generative Pre-trained Transformer Model, or GPT for short. So what's the meaning behind the name? Generative means that the model is capable of creating new text. So basically, that's the function of the model. Pre-trained means that the model has been pre-trained on massive amounts of data prior to using it. And transformer is referring to this specific neural network architecture that we just mentioned. Actually, if we are talking really specifically, this is the architecture of the GPT model. It uses just the decoder part of the transformer architecture because it's not translating from one language to next language. It's just using initial prompt to generate a lot of that language, a lot of text, right? So it can loop. It can loop from one starting point. It predicts the next word in that text, adds it to the starting point, and goes back through this loop as long as it thinks it needs to keep adding text until it has the meaningful answer to the user's prompt, to user question. So how was the GPT actually trained? So this used OpenAI or GPT-3 makers. They used two modes of training. So the first phase was unsupervised pre-training, where GPT was trained on a large corpus of text data to learn the underlying patterns and structure of language. So this pre-training involves predicting the next word in a sentence, and using this transformer-based architecture to do this. It's really important to try to get models to do this with unsupervised training, obviously, because nobody would be able to prepare such a large data set if we had to label each sentence with like, okay, this is the next word that comes naturally after it, and so on and so forth. The supervised fine-tuning phase is when the pre-trained model that already understands the language is trained to do specific tasks like question answering and stuff like that, and it's also trained to be safe for kind of consumer consumption, right? One interesting thing that I still need to mention about these models that we're going to use a lot in our demo and later in discussion about use cases is semantic vectors or word embeddings. So any neural network really doesn't operate on text. It operates on numerical values. So how do you represent a word or a sentence or a piece of text to a neural network? So neural networks have to convert everything they see into numerical representation. In this case, what the GPT does is takes each word and converts it into a series of numbers that really represent the meaning of that word. So that when you put those numbers together, words or words that have the similar meaning have basically the similar numerical representations. And if you think about those series of numbers as vectors, we can do some interesting vector math with them to find similar words and whatnot. That comes kind of handy later. So how do we now that we know how this thing works kind of in the background, how do we build solutions that take enterprise data and turn it into easily accessible knowledge? The process is this. Like, first of all, we need to do a lot of semantic indexing. So we need to understand what is the data that we want to expose to our users. And then we go through semantic indexing, basically pass that data into these APIs that are called embedding APIs, which give us, again, like that semantic vector, the numerical representation of the meaning of that piece of data. We then store those embedding vectors in a vector database. And vector databases is this relatively new technology that is optimized to compare large sequences of numbers using either Euclidean distance or this cosine distance, which is like the vector distance, and basically give us back the words or pieces of data that are the closest in meaning to our query to the database. So once we have a lot of data indexed, stored in the vector database, of course, at that time we need to worry about how are we doing data segmentation? Is the access to that knowledge secure? between users and whatnot, and what's the cost, because there are obviously all these APIs. Some are free or can be free, some are expensive. So once we do that, then we need to implement our query logic using completions API. So completions API is really where the magic of GPT comes to light, right? So we find the interesting pieces of reference data, then we take the user's question and pass all of that together to GPT and tell it, okay, based on this reference data, please answer user's question. And thanks to the few-shot learning magic, large models are able to intelligently consume that context and give us an intelligent answer. And then at the end of it, obviously, if there are some answers that are not really accurate, because again, few-shot learning is not perfect, we fine-tune the model by using large sets of pre-generated question answers, where we can actually, this is supervised obviously training, where we edit those answers in a way that we want the model to answer them. So we fine-tune the model, and then it becomes more accurate and safer to use. Front end to this can be anything, right? So we typically so far use chatbots and voice bots, but any type of app, can do this and put it within the structure of the app for some really, really cool user experiences. Just to show you what the different big models do for few-shot learning, the GPT-3, which is, we saw the demo for GPT-4 2 days ago, which is already way smarter and super exciting to use. So we already have access to it. Guys are actually playing with it. But we already know that the GPT-3 had huge advantage in accuracy over the previous models for a few shot questions. And it's not the biggest one by any means. So you can see on this diagram, GPT-3 with 175 billion synapses or parameters, more accurately parameters, right, is like small compared to some of these research model at 500 billion parameters. And we know that Google is soon coming out with a 1 trillion parameter model. OpenAI is going to come with one as well. So I think in a few months from now we're going to be just 3 orders of magnitude behind our own brains. So that's going to be really exciting times. At this point, I would like to just show how we internally use this technology to help our people kind of access corporate policies. So let me share. Let me share the web page first. So I hope you can see it here. Yeah, okay. Perfect. So what you can see here is that is basically a folder in SharePoint with a bunch of our corporate policies. And these are real policies that we Authority Partners use to, kind of codify how we do things, various things. How we train people to really understand and follow these rules is, usually we have an onboarding process where even before join, people need to read some of these things. Once they join, then like we have a 3-month mentorship process where we try to get people familiar with most of the stuff that they need to do their job. However, the problem is that we have these things called continuous improvement process or process improvement processes, and these policies change all the time. So how do we optimize training and retraining of people is always kind of an issue for us. And people asking, okay, is this my responsibility or is this somebody else's responsibility? stuff like that gets kind of hard. So what we did is we kind of connected this to a little bit of our framework to translate this into knowledge, and then let people ask questions about these policies using just a regular chat assistant, right? So here's MS Teams, like the situation is for a lot of people using Office 365 or Microsoft technology. Obviously, we are building connectors to Google Chat and others, so no worries there. But we use a lot of Office 365 technology ourselves. So here I can ask questions like, for instance, what is program management, right? And our assistant is thinking hard about it. What the heck is program management? And it gives me the answer. Program management is the process of initiating, governing, and ending programs, blah, 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 blah. Basically, and it tells me, okay, here is the list of documents where I found that information ranked in the order of importance, right? The roles and responsibilities for information security, program management policy, and so on and so forth. So this is where it found the information. I can ask it stuff like, what is a difference between, let me do this. What is the difference between Scrum Master role and Program Manager role? Again, it's going to go off and tells me, okay, Scrum Master is doing this, facilitating the Scrum process, ensuring that the team is following the Scrum framework. The Program Manager is responsible for managing the program and ensuring the program is meeting its goals and objectives. That's kind of short, but if I want to see more, I can, look at some of these policies that it showed me, click on it, and kind of really read the substance of the whole thing. The interesting thing is that the question that I just asked, what is the difference between Scrum Master and Program Manager? I can actually ask in any language that I want. I can ask it in Bosnian, and I hope this is not an Elon Musk moment where they break the car window. Okay, it actually is. It answered in English. So you can see that it did understand my question, but I guess because I used a lot of English words, it answered in English. I'll try to ask in Spanish. This is Google translated Spanish, and some of my Spanish speaking colleagues are gonna say this is cheating. It's not right. Okay, but this time, because I was using more Spanish words, I guess, in it, then it's giving me an answer in Spanish. And this is not like we are not doing any kind of language recognition here or any programming. All of our policies, if you click on them, like program management policy, how do we do program management? It's all really in English. That's our company language, but GPT, recognizing that the question is being asked in Spanish, it's gonna translate its own question to Spanish. And just because it's dealing with meaning, it doesn't really care what language we ask the question in. So I'm gonna ask it to, obviously it knows these simple answers, simple questions. I'm gonna ask it a little bit harder question, like, what is the meaning of life? Okay, let's see if it knows. Okay, so it doesn't know the meaning of life. Good. So you can see that if it doesn't really know the answer to a question, it's gonna tell us, like, and we can configure this. We can let this question where we go to our vector database and we don't find any reference information. We can decide to, say, okay, I don't have enough knowledge to answer your question, which we are doing today, or we can pass that question anyways to GPT and let it use its vast 175 billion parameters that it kind of configured from learning from open internet, all kinds of data, and we can let it answer the question to the best of your knowledge. So that depends on your use case, whether or not you want to pass that data to GPT or not. But if I wanted to, augment its knowledge to let it know what is the meaning of life, of course, I can say office.com. I can go to Word and say, okay, this is the meaning of life policy. And I can say the meaning of life according to Douglas Adams. Sorry. It's of course 42, right? So we will say this thing, and then I'm gonna now show you the magic behind this whole thing is this app, right? This is the admin app for this solution behind it. So it sees all of our policies, and suddenly, okay, let me actually go to SharePoint, sorry, and add that policy in there. So I'm gonna say upload files, and it's gonna go to meaning of life, open. So we can see that SharePoint is adding this meaning of life policy. What I want to check is if our admin thing is picking up the meaning of life policy. Here we go, meaning of life. Sorry, it took a little bit to find it. And if I had this whole folder set to automatically index things that are in it, then it would automatically add my policy. In this case, the whole folder was not clicked, so I had to do it manually. In any case, if I go back to our helpful assistant and ask it now, what is the meaning of life? Now it should know what the meaning of life is. Let's see. Yeah, the meaning of life, the universe, and everything is 42, and it's giving me the policy that it found about the meaning of life, right? I can click on that. It gives me my SharePoint policy. I can change my mind, say it's 43, and just save it, and it's gonna think that the meaning of life is 43. So that's basically in a nutshell how this thing works. The solution is all, here basically we just connect it to whatever data source we have. It is continuously scanning it for changes and additions, deletions, and whatnot. I can uncheck a whole folder of stuff, and it's gonna remove them from the knowledge base, or I can then again click it, and it's going to be adding these things to the knowledge base by again semantically indexing them and storing them into vector database. Here is our knowledge base. So the whole this whole source data is translated into these, broken up into these little sections based on some strategy that you can customize. And that's what we search through when the user asks questions. So what is the meaning of life really should pull up, here. The meaning of life according to Douglas Adams is 43. That's the top result according to our semantic search. So that'll be it about this solution. I'm gonna now go and talk a little bit about some of the other use cases that we can do. Okay. So real quick, use cases. Obviously, this use case showed something about using document as a data source and extracting meaning from documents, basically raw document content. Obviously, we can do document summarization. We can extract feature from documents. It can extract names, places, dates, who is conversing to whom, who is relating to what, contract management, customer support, obvious case for some of these, right? It actually looks like customer support, the demo that I just did. Then we can do async communication, email, chat, whatever. We can summarize the whole thread of communication or a channel in async, in chat. We can inject some metadata in it, and we can ask questions like, okay, is anybody bringing up this topic? Who is bringing up this? What is this person talking about in this chat? What are some action items that were discussed in the chat and whatnot? Business analytics and live data, another really interesting set of use cases. We tried passing database structure and the question to GPT, and we asked it, okay, can you give us the SQL query that's gonna actually answer this question based on this database structure? And it gives us really great, almost flawlessly great SQL queries that we can then run in the background, produce that data, give it to the user. We even try to visualize it automatically. I mean, it has all kinds of stuff that it can do. And finally, we are a software company. Obviously, we do a lot of it, technology organization data, pull requests, user stories, change requests. It can automatically generate unit tests. It can automatically summarize, pull requests, something that the developer checked in, so the architects can speed up their work and whatnot. So really, really cool stuff that we can do. Now, I'm trying to speed up a little bit, but we do really want to get your input here. What, in your opinion, would be a use case that's really interesting to you? So if you don't mind going to the polls window in your right hand bottom corner and just answering which one of these areas sound like something you would like to solve with generative AI, and maybe you have something else. So if you don't like any of these, or you have something else on your mind, just click on other uses, and we'll certainly be interested to know what that is. If you can send us an email, we will really, really appreciate it, because our R&D team is kind of crunching through all these scenarios. Moving on, I just want to say a few words about how we approach these things. So Authority Partners, we started 25 years ago in Southern California. Since then, we built 3 more technology centers. One is in Santo Domingo, Dominican Republic, another in Sarajevo, Bosnia, and a third one in Istanbul, Turkey. I just was going west to east. But incidentally, this makes our company run on 3 continents. Actually, have technology centers on 3 continents. We have remote people working in 30 other countries. We are very specialized in remote work, to be quite honest. We have more than 500 consultants on 5 continents in 13 time zones, able to commit 15,000 engineering hours every week to bring to your projects. How we engage, pretty simple, starting with staff augmentation. If all our clients need is great people, we can provide that in any role possible. Then our bread and butter kind of managed team, we create a pod that's able to crunch through any sort of backlog and produce a working software. Then build engagements where we take more responsibility over the actual product management and roadmap and feature design. We talk to your business users, your subject matter experts, and obviously technology folks to create the backlog that we then obviously produce. And transform is this service offering where we, our R&D folks, engineering managers, and other high-level people can help our clients' technology organizations adopt best practices and new technology strategies. Across those services, we have different capabilities. Cloud systems, obviously, we are cloud native, as well as we know how to migrate things to cloud. Web and mobile applications, any format, any technology stack. Natural language interfaces for enterprise data, we just talked about that. Business intelligence analytics, obviously every project has this. Product management and design, and then technology strategy and best practice adoption in cloud, DevOps, microservices, agile, test automation, and generative AI. Finally, we are technology agnostic, so any tool will do. We'll pick the best tool for the job. And our method that we evolved over the last 25 years, we engage with you through workshops and private meetings to align. Then we go into a discovery engagements where we co-create and ideate together to create a statement of work for delivery phase. During the delivery phase, we iterate, from sprint 0 to MVP and continuing on to final delivery, where we, hand over that software to either our client's team or we create a managed services engagement for continued care and maintenance of that software asset. This was fast. So we are ready for questions and answers. Again, this Livestorm platform provides the questions window, and we'll be happy to select some of your questions. But don't worry, if we don't get to all of the questions today, we will certainly answer them through email within a day or two. Thank you so much. So, questions? So I see I have a question. Is this solution usable for detecting potential risks, such as operational risk, fraud, or some other kind of non-logical data in the system? Obviously, we would need to look into your particular use case to answer this question. It's specifically, I think that custom network with some structured data sets that is maybe better for pattern recognition. But if we can describe some fraudulent cases using context data and then feed the actual real-time cases to GPT, then we can see like maybe it can actually, using the few-shot learning, detect, okay, what situation is fraudulent, what's not. I see people asking like, how long did it take you to build this solution for you? This is really, something that we put in like 3-4 weeks with 3 dedicated guys and girls. But the thing is that, these people have unfair advantage. Obviously, we are playing with these technologies for a long time, so they knew what they were doing. But it's very useful solution, and we have a framework now with all kinds of connectors that we can license to our clients, or if we engage with them for a custom solution, obviously, then we can discount the price of that license heavily. Other questions? Okay, security question. Security, obviously, that's the very, very important part of it. For custom solutions, we already know how to see if a person has access to that source data or not. So when we are picking up knowledge from the knowledge base, we will not even pass the context to the GPT that the user doesn't have access to. And we can have all kinds of security strategies for custom solutions, right? So where do you want this stored? Is it on premise? Is it within your I don't know, Azure or AWS subscription or something, or whatnot? Pricing model for integration with GPT. Sure. So we have some estimate of cost. We'll answer this through email. It's not a lot. Like for thousands and thousands of questions, it's basically in singles of dollars or euros, so it's not a lot, but obviously everything plays a role. Data storage, indexing, how much data do we have to index in the first place, and whatnot. Using it is not that complicated. So at this point, I'm gonna cut off the questions, move on to the last poll of the day. I'm sorry, I know that some people are already leaving, but your level of interest. Please let us know if you would like to find out more. We have, I'm available for private meeting, or Nella is waiting eagerly to meet with you. Also, if you'd like to brainstorm with your team and our solution architects about your specific use case, we can create a free workshop and really co-create some sort of solution for you. And if you're already working on a solution, you can use some help, let us know. Or you have no further questions at this time, we are not going to bother you too much after this. So if you don't mind, just go into your, again, bottom level corner. There's another poll, if you can answer that. Finally, I think we've covered a lot of ground in this webinar, exploring the GPT and fundamentals of artificial neural networks. So I hope it has given you a better understanding of the exciting developments happening in the field of generative AI. So thank you for joining, and thank you to our amazing team. And here is Onela to close us off. Thank you.
Thank you, Errol, for this insightful presentation, and thank you all for attending the webinar. And special thanks goes to our incredible Authority Partners team who worked tirelessly behind the scenes to make this event possible. I hope you all enjoyed the event and you found it informative and valuable. Have a great day, and I look forward to connecting with you soon. Thank you and goodbye.